we want to solve this equation. We're going to use a strategy just the same as that we've used before. We're going to let x of t equal a e to the rt. I'm using r in this case instead of k simply because r is more standard for this notation. So at this point we're going to, for this kind of an application, for this point, at this point then we're going to switch to r instead of k for the variable. Okay, so now if x of t equals a e to the rt, then suppressing the t notation, we see that x prime is going to equal r times a e to the rt. X double prime is going to equal r squared times a e to the rt. Substituting these expressions into this equation, we get r squared a e to the rt plus we have gamma over m x prime, so that's going to be gamma over m times r a e to the rt, and then plus g over l x, so we're going to have g over l times a e to the rt equal 0. Dividing through by a e to the rt, we're left with just r squared plus gamma over m r plus g over l equals 0. We recognize this as a quadratic equation. This is simply quadratic equation of the form a r squared plus br plus c equals 0, with a equal to 1, b equal to gamma over m, c equal to g over l. You might want to pause at this point and plug these values into the quadratic formula and see for yourself what we get. Whether you've done that or not, the result is r equals negative b, which is negative gamma over m, plus or minus the square root of b squared minus 4ac. B squared is going to be gamma squared over m squared, and a is 1, c is g over l, so this is going to be 4g over L, and this is all going to be divided by 2. Now let me make my gamma look a little more like a gamma, a little less like an R. You can see how there could easily be some confusion there. Okay, so I'm going to write this R as R equals negative gamma over 2m plus or minus the square 1/2 square root of gamma squared over m squared minus 4g over L. And we'll spell this out, but I'm simply going to comment that the nature of this solution depends on whether this quantity under the radical is positive, negative, or 0. If it's positive, then we're going to have a positive number here that we're going to either add or subtract from gamma over 2m, giving us 2 real solutions. If it happens to be 0, then this term is 0. We get only one solution, negative gamma over 2m. And if we have a negative under the radical, in other words, if our discriminant is negative, we're going to have an imaginary part here. The square root is going to be an imaginary number. So we're going to have a real number, gamma over 2m, plus or minus some imaginary number. And that's going to have a significant effect on the conclusions about how this pendulum with this drag force actually behaves.